So, a quick recap. We've been looking at linear graphs. So, when we've got a rule, we need to find some points and then we can plot the linear relationship on a Cartesian plane. So, this is one we've looked at before. Y equals 2x plus 1. If we substitute x equals 2 into that equation, we end up with y being 5. If we substitute x equals 1, y will be 3, and so on. And then we can plot those points on the Cartesian plane to show our linear relationship. Now, what we're going to be doing in Unit 6.3 is a little bit different and a little bit trickier than that. This is about actually finding the rule. So finding the rule that explains that linear relationship, that connection between the x and y coordinates. Now, to find a rule, we first need to start with some coordinates that we use to find the rule, and the coordinates could be provided to us as a bunch of ordered pairs. So we could have a bunch of coordinates that we're given, and we need to find the rule that connects these coordinates. We could have a table of values. So again, we'll have the x and the y coordinate, and then we've got to find the rule that explains this relationship. Or the third way we might be provided with the information is on a graph. So we will already have the linear graph, and we've got to work out what the rule is that describes this graph. So to do that, you would need to pick a few points on the graph. So we might say here we've got this point, which is 2, 8, because it's 2 on the x, then 8 on the y. This one is 0, 2. This one is negative 2, negative 4. Negative 2 on the x down to negative 4 on the y. So we can find a few coordinates from the graph and then use those to find the rule. So whatever we're provided with, we use some common strategies to work out what the rule is. So to find the rule, we need to look for some patterns or look for a connection between the x and the y coordinates. So the rule that we come up with will take this form. It's got to connect the y and the x. What operations do we need to perform to the x to get the y value? So we might only need to perform one operation: multiply, divide, add, subtract, or we might need to perform two operations. So it could be something like y equals 3x. So we don't need a constant. So we've got to multiply the x by 3. Could be y equals x over 2. So we've got to divide the x by 2. Could be y equals x minus 3. So we've got to subtract 3 from x to get to the y. It could be something like y equals 5x minus 2. So we've got to multiply by 5 and then subtract 2. So we've got to perform two operations. So something like 7x, y equals 7x plus 10. So we've got to multiply it by 7 and add 10. So by looking at the table of values, you've got to try and look for these operations. Look to see if you can work out what operations were performed on the x to get to the y. So looking at our first table, see if you can work out what operations have been done to the x coordinate to get to the y. Maybe pause the video for a second and see if you can work it out. So hopefully you might have noticed, to get from 3 to 12, we could multiply by 4. We could also add 9, but that doesn't fit here. 2 plus 9 will be 11. Okay, so it can't just fit one coordinate, it's got to fit all the coordinates. So let's see, 2 times 4 is 8, 1 times 4 is 4, 0 times 4 is 0, negative 1 times 4 is negative 4. So multiplying by 4 fits all of our coordinates. So the rule must be y equals 4x. The x value has to be multiplied by 4 to get to the y value. Okay, here's another one. Again, pause it and pause the video and see if you can work out what operation has been performed. Okay, so hopefully you might have noticed that there's a gap of 3 between each of our coordinates. So 2 plus 3 is 5, 1 plus 3 is 4, 0 plus 3 is 0, and so on. So again, adding 3 fits all of our coordinates. We could say 1 times 4 is 4, but 2 times 4 is 8. That doesn't fit. 0 times 4 is 0. So the rule has to fit each of the values that we've got. So the rule, when we write it, would be y equals x plus 3. Because the x value, 3 is added on to get to the y value. So those were some examples where there was only one operation performed, but that won't always be the case. Sometimes there'll be 2 operations that are performed on the x value, so it can be a little bit trickier to work out the rule. So here's our first example. So we need to see if we can find any patterns, any connections between the x and the y. So again, pause the video and see if you can work out what the connection is, or see if you can find any patterns in the table. Okay, so one thing that you might notice is that our y values are increasing by a constant amount. It's going up by 3 each time. So as the x is increasing by 1, the y value is increasing by 3. And so that's important because that tells us the coefficient of x. It tells us what number to put in front of the x. That's because this is telling us what to multiply x by. So for every 1x, there is 3y being added. So that means that our rule must be something like this: y equals 3x, because for every 1x, there's 3y. But that's not the finished rule, because if we have a look, y equals 3x, 4 times 3 is 12, 3 times 3 is 9, 2 times 3 is 6. So that's not exactly right. There must be another operation. So there must be a constant as well that we've got to add or subtract from or to the 3x to get to the answer. So hopefully you can see we're pretty close. 4 times 3 is 12. If we plus on 1, we'll get to 13. 3 times 3 is 9. We plus 1, we get to 10. So the final rule is y equals 3x plus 1. Okay, let's have a look at another one. So this is similar. There's 2 operations again. So pause the video, see if you can find any patterns. Okay, so if we take the same approach as last time, 8 to 13, that's going up by 5. 3 to 8, that's going up by 5. Negative 2 to 3, plus 5. So again, we found our coefficient. It must be y equals 5x, because for every 1x that's increasing, there's 5y. So we've got to multiply it by 5. But is that the whole rule? 3 times 5 would be 15. 2 times 5 is 10. 1 times 5 is 5. So that's not exactly it. What do we need to add or subtract? If 3 5s are 15, we can subtract 2 to get to 13. 2 times 5 is 10. Subtract 2 will get us to 8. 1 times 5 is 5. Subtract 2 gets us to 3. So 5x minus 2 is the finished rule. So remember, you have to check that the rule fits multiple points. You can come up with any sort of rule to just fit one of your values, because we could say y equals x plus 10, and that would work here. 3 plus 10 is 13, but it doesn't work for our other points. So make sure that your rule fits all of the coordinates that you've got. Okay, we'll do a couple more. So again, this one is a little bit different because in our table, x isn't going up by 1 this time. X is going up by 3. Okay, and we need to take that into consideration when we're working out the rule. So pause the video, see if you can find any patterns in our table that we can use to find the rule. Okay, so hopefully you've noticed the y coordinate, is going up by 6 each time. So last time we said that this tells us the coefficient. So does that mean that it would be y equals 6x? If we substitute x equals 9, 6 times 9 is 54, so that's not even close. So it's not 6x, because we want to know how much is just 1x worth for the y coordinate. So we need to divide this by 3. So as x goes up by 1, y would go up by 2. So it's not y equals 6x, but y equals 2x. So let's try that. Substitute x equals 9. 2 times 9 is 18. 2 times 6 is 12. 2 times 3 is 6. So if we subtract 1, we'll get to our answer. So let's try a couple. Substitute 3, x equals 3. 2 times 3 is 6, minus 1 gives 5. 2 times 0 is 0, minus 1 gives us negative 1. 2 times negative 3 is negative 6, minus 1, negative 7. So that's our rule, y equals 2x minus 1.